Number 9 is working with composite functions, and those are kind of fun to work with. They're just nested functions, and you always work from the inside out. So, on this part A, we want f of g of 1. So you're going to work with this one first. So g of 1, you go into the g function only with a 1. And 1 squared minus 1 is 0. So now you're going to replace g of 1 we just evaluated is 0. Now look what this says. It says go into the f function with the 0. So that's exactly what I'm going to do. I'm going to do the square root of 0 is 0. Done. Pretty easy. Now part B says to do g of f of x. So we're going to go into the g function with the f function, and the f function is defined to be root x. So now we're going into the g function with that value. So here we go. The g function is right here. So it says to take this value for x and plop it in wherever you see an x. So I have root x. Don't know why I wrote it 2. It says to square it and subtract 1, which gives me x minus 1. And you've just evaluated both A and B with composite functions. Number 10 says you have 200 feet of fencing to enclose 2 adjacent rectangular fields. So all the way around this fencing, there is 200 feet of fencing. All the way around here, there is fencing that is 200 feet in length. And it wants you to express the area, and we know that area is length times width as a function of x. So that means you can't have any y values in it. So let's see what we have so far. Area is length times width. So I've got the length to be 2x, and I've got the width to be y. Problem right now is this y right here. If it's as a function of x, you cannot have that y in there. But I have other information I could possibly use, and maybe I have a secondary equation that I could use. So let's see what I can do with this 200. We talked about it surrounding the adjacent fields. So I know that 200 is equal to, that's the perimeter, is equal to the perimeter of these rectangles. So I have how many x's? 1, 2, 3, and 4. So there's 4 x's, and there's 2 y's that make up that perimeter. So here's your secondary equation. Could I solve for y here and substitute it into the area and just have a function of x? Yes, indeedy. So let's play around with this. You have 2y equals 200 minus 4x. And if you solve for y, you get y equals 100 minus 2x. And you take this value of y, travel, plop it right in there. Therefore, here's my therefore. You'll see me do this a lot. Area equals 2x times the quantity 100 minus 2x. And you've just expressed area as a function of x and only x. Number 11 conjures up your trig. I don't know if it's a nightmare or a very good dream for some of you, so here we go. We have if sine is greater than 0. So where does that happen? Sine is greater than 0 happens here and here. It says to evaluate the sine of theta if tangent of theta is a half. Did I just make a big blunder? Hopefully you guys caught that. Sine is not greater than 0 here. It is here. I was looking at I was reading ahead and doing tangent. Remember, all students take calculus? All students take calculus. That's how you tell which of the trig functions are positive. All the angles are positive here. Only sine ratios are positive there. Only tangent, only cosine. Hopefully you learned that. Now, so let's draw this again so I don't have a big mess. If you have sine positive here and here, and tangent positive here and here, the only place that they are the same sign is in quadrant 1. So you know the angle has to be in quadrant 1. So if tangent is 1 over 2, that is opposite over adjacent. Since we know this is a right triangle, we know this is root 5. So it says to evaluate the sine of the angle is opposite over hypotenuse. And you have just found the sine of the angle given only the tangent. And in calculus, you can leave your answer like that. You do not need to rationalize your denominator.